All right, so let's get started with topic 1 of lesson 1 for this unit on trigonometry. We're going to be talking about the unit circle in this section, and the unit circle really is the basis for how we define things in trigonometry. So we're just going to talk about the unit circle in this topic video, and in the next one we're going to use the unit circle to define the operations of sine and cosine. So that being said, take a look at this image that I have for you here. This is a picture of a unit circle. As you probably guessed, a unit circle is a circle, and it's called a unit circle because the radius is 1 unit long. You see these points 1, 0, 0, 1, negative 1, 0, 0, negative 1. It shows that we have the circle laying right on top of the origin of an xy axis. So this is like the x-axis, this is the y-axis, and the unit circle itself is radius of 1 unit laying on the center of the xy coordinates. An important question would be, what is a unit circle and how does it relate to angles and to trigonometry? To get started, I want to kind of get us back to the most basic idea in angles, and that's that we define degrees as being units of a circle. So like if I have a full circle, we talk about it as 360 degrees. Or if I had half a circle, we talk about it as 180 degrees. Or if I had a quarter of a circle, we talk about it as being 90 degrees. And that's something that we typically cover way back sometime in elementary school. And we can apply it here to this unit circle, thinking that if I were to use this as our starting point, which in case you're curious, this is going to be our starting point, and we had this be where we started talking about 0 degrees, we could count up 1, 2, 3, 4, 5, 6, 7, a bunch of tiny little degrees, and it's kind of hard to decide exactly where in here is 1 degree versus 5 degrees versus 10 degrees. But there are a few important ones. If I was to move from 0 degrees to here at the top, we could definitely say, oh, that's a quarter of a circle, that's 90 degrees. Or if I were to continue moving a little further all the way to halfway around the circle, we could agree that that's 180 degrees. We don't normally talk about this, but 3/4 of a circle would be an extra 90 degrees, right? 90 plus 90 gives us 180. Go another quarter of the circle, that's 270 degrees. And then if we get back, that's 270. For some reason, my pen keeps hiccuping here. And then as we get back around full circle, we'd call that 360 degrees. And in fact, 360 and 0 kind of get the same location. 0 was our starting point, then we went all the way around the circle and got to 360. And in between 0 and 90, there are 90 other degrees along this, this portion. And then there are, another 90 degrees in here. We can maybe say, we can guess, say between 0 and 90 degrees, we could say that 45 degrees was around here. Whoa, another hiccup. 45 degrees. Or we could say, well, we could break 0 to 90 into thirds, right? So maybe 1/3 of the way to 90 would be 30 degrees. 2/3 of the way to 90 would be 60 degrees. So we can kind of imagine along this circle, almost like a clock, that any degree we wanted could fit into this image, into this picture. And one thing that I want to, you might think, oh, well, why not start at 0 degrees here, count all the way around the circle, and then, we'd have 360 degrees. So by the time we get back to where we started, we would be at 360. But I'm going to say that one important thing when we talk about the unit circle is where we start matters. So typically when we've talked about, oh my goodness, it just doesn't want to work. Where we start matters. Wow, I have to write it like 3 times. And usually when we've talked about circles and dividing up portions of a circle into different degrees, we haven't really cared about a starting point and an ending point. We've more just considered like portions of a circle. Half of a circle is 180 degrees, that kind of an idea. But in the unit circle, we actually want to think about it almost like a clock, where this portion right here is the starting point, and then you can think about it as if the hand was moving up and around and back to its starting point. So we have, it's like a clock, but it moves counterclockwise. So counterclockwise. And it starts on the x-axis as it goes around. So that is the unit circle. It's not anything really like earth-shattering, just a circle that we organize degrees around. Now, something that I want to mention before we move on to talking about sine and cosine in the next video is what do we do if we have a degree measure that isn't between 0 and 360? So notice on this, I've started at 0 degrees, and then I've gone upward to 360 degrees, and that's where I finished, because that's the measure within a circle. Well, it is possible to talk about degrees that are less than 0, actually, so like negative degrees, negative 10, negative 20 degrees, or it could be possible to talk about degrees that are more than 360 degrees, like 400 degrees or 500 degrees. And we want to talk about what that would actually mean when we are looking at a circle. So let's start with negatives. Let's say we were talking about the measurement of negative 10 degrees. Well, if we define going around the circle in the proper direction, starting here at 0 and then going counterclockwise, then when we talk about a negative angle, it just means that we're moving backwards. So here's our starting point. If we want to know where negative 10 is, instead of going the correct direction, which is counterclockwise, we'd move backwards about 10 degrees, which let's say it's about here, and we'd call this negative 10 degrees. So basically 10 degrees before 360. So another way of naming negative 10 degrees would actually be 350 degrees. If you think about it for a second, what would it be if we were 10 degrees before 360? Oh, well, it would just be 350 degrees. In fact, we call negative 10 and 350, we use a term called coterminal angles. You can write that down if you want. It's coterminal. Well, and what it means is that we have, sorry that this is like, I don't know why it's hiccuping. It's just like lagging on me for some reason. Just started doing that. Okay, so coterminal angles are angles that are basically two names for the same position. So to say negative 10 degrees and to say 350 degrees, they're both put you at the same place on the circle. If I say 350, it means I'm going to start at 0 and I'm going to move the right way, which is counterclockwise, around the circle, and at 350 I stop. Here's 350 degrees. If I say negative 10 degrees, it means I start here at 0 and I go backwards negative 10 degrees and I end up at the same position. So that's what it means when we say that these two angles are called coterminal angles. And we generally, if I have to name an angle, we usually use the one that's between 0 and 360 just because it's more conventional. In fact, we call that the reference angle. It's the one that is more accepted because 0 to 360 is our more traditional way of talking about degrees within a circle. But negative 10 and 350 are still coterminal. Okay, so that's what it means to have a negative angle. Now, an angle that's less than 0. But what happens if we have the other side of the spectrum? What if we have an angle that's above 360, so say like 400 degrees? We might ask, well, what does that mean on our unit circle? Well, for 400 degrees, it's a positive angle, so we're going to travel around the unit circle at the proper way. That means counterclockwise. So we'll start at 0, and we'd start going around the circle all the way, 180, 270, 360. We've made a full circle, but we're not all the way to 400 degrees yet. In fact, 400 is 40 degrees past 360. And so that's what we do. Just like a clock where the hand keeps going around and around and around, we're going to pass 360 and go 40 degrees more, which is right about here. So like if we think about it like the hand of a clock, if it's going around and around, right about here is 40 degrees past 360, or in other words, 400 degrees. 360 plus 40. So 400 degrees or 40 degrees are actually coterminal angles. They're angles that exist at the same position on the unit circle, but they're two names for the same angle. Now the more traditional one is going to be 40, because typically we name angles between 0 and 360. Again, we call that the reference angle because it's the more traditional way. But to say 40 degrees or to say 400 is actually the same measurement. And again, it's because if we just trace our cursor here around the outside of the unit circle and we go past 360 to 400, we land at the position for 40 degrees. So we can have angles of any number. We could have negative 100,000 degrees, and we could figure out what that would be. I mean, we'd have to be traveling backwards, and we'd have to go spin around the unit circle a whole lot of times to get negative 100,000 degrees. But that angle is something we can figure out. We can figure out where it is. Again, in the positive direction, we could have positive 100,000 degrees. It just means that we travel the correct way, counterclockwise, and we just keep spinning around and around and around the unit circle until we came to that position for 100,000 degrees. Okay, that is the unit circle. That's how it works. Any degree that you mention, we can locate its position on the unit circle and we can give it a name with a reference angle. So that is all I have to say for topic 1. Now in the next video we're going to talk about how this applies to sine and to cosine.